Hey everybody, this is Mr. Bear. I'm bringing you Skill 18 video, and so today we're going to talk about how to solve exponential and logarithmic equations. So we're going to start off by solving exponential equations that actually don't need to be written with log form to be able to solve. If we start with this very basic first example, see how the 3's already have the same base? When that happens, you can just set the exponents equal to each other. And in this case, x is just going to equal 6. So 3 to the 6th equals 3 to the 6th. Not too bad. For the next one, if I look at the number 25 and the number 125, both of those can be written with a base of 5. So 25 is 5 squared, and 125 is 5 cubed. And then what we're going to do is we're going to multiply our exponents. So we're going to get 5 to the 6 equals 5 to the 6x minus 12. I'm distributing that 3 from here. Now that we have the same bases, I can just do 6 equals 6x minus 12 and solve for x. So we're going to get, let me write this up here, we get 18 equals 6x. So dividing by 6, we would get x equals 3. All right, let's change color here. For this next one, we have 3 to the 2x minus 1. Let's see, 81, I can write that as 3 to the 4th. So I'm going to do that. And then I'm going to multiply my exponents on the right side. And now I'm able to set my exponents equal to each other. And notice here, we're not going to get a whole number. That is okay. 10.5 is fine. 21 over 2 would have been just as fine. All right, looking at the fourth one, we have 1/8, which I know is going to be the same as 1 over 2 to the 3rd, which is the same as 2 to the negative 3. So I'm kind of going in reverse of what we would normally do with exponents. And 4 I know is 2 squared. Okay. So I'm going to multiply my exponents. I get 2 to the negative 6x equals 2 to the 24. And now that the bases are the same, I can just set the exponents equal to each other. Divide by negative 6, and we get x equals negative 4. All right, so that's how we're going to solve equations of this type. So now what do we do when we have equations with logarithms? Well, first of all, if you have a logarithm that has the same base on both sides of the equal sign, then you can just set the arguments equal to each other. Okay? So x in this case equals 5. So just set arguments equal to each other. Make sure to condense first. If necessary. Okay, that's why we learned the skill that we did last time. Also remember that the value inside the logarithm must be positive. So any answers that give a negative value in your logarithm are not real solutions. And we'll see those pop up. All right, let's look at this example. On this example, I don't need to do any condensing of logs, and the reason for that is because each side of the equation just has a single log written. I know you might be sitting here thinking, Mr. Bear, I see a minus sign here. If the minus sign were between two different logs, you would condense. But in this case, the argument is just 5x minus 6. Okay, so the way we're going to solve this, since the logs have the same base, we're just going to cancel those out, and we just get x squared equals 5x minus 6. Thinking back to what we would do every time we solve these kind of equations in Algebra 2 in the first semester, we would make one side equal to 0. So what I did was I subtracted the 5x from both sides, which is why I have minus 5x, and to get rid of the minus 6, I had to plus 6. So now the goal is to factor this. So I'm looking for two numbers that multiply to 6 and add to negative 5. That's going to be negative 3 and negative 2. So x minus 3, x minus 2. Solving these out, we get x equals 3, and we get x equals 2. And we want to check and make sure that these values of x work. So let's see, if I do 3 squared, we get 9. That's good. 5 times 3 minus 6 is going to be 15 minus 6, which is 9. Both of those arguments are fine, so x equals 3 is a valid solution. Plugging in 2 for x for each of our arguments. 2 squared is 4, and that's good because it's positive. 5 times 2 minus 6 is going to be 10 minus 6, so that's 4. That works. So both of these solutions work. Okay? All right, for the next one, to solve this one, we have to first condense these logs. We have a plus sign in the middle, so we're going to use the product property. So I'm going to have log base 4 of the quantity 2x equals log base 4 of 3x plus 5. Notice this time that plus sign in between the 3x and the 5, that's just part of the argument. It is not separating two different logs on that side, so I'm not doing any condensing there. All right, now that I have those and I see that the logs are the same on both sides, I can cancel those out and I get 2x equals 3x plus 5. Subtracting 3x on both sides to get my x's to one side, I get negative x equals 5, which means x will equal negative 5. Maybe. Checking your arguments, if I plug in negative 5 to this x right here, we get a no-no. If even one log argument is made negative with a solution, you have to throw it out. So this is invalid, which means there's no solution this time. Okay, so keep in mind that that could happen. All right, looking at the next one. So on these, what's different about these equations is that we don't have a logarithm on both sides of the equal sign. Okay, so what we're going to do is we're going to still condense, like so. Here I have a product property to use. So when I condense this, it'll be log base 2 of 7 multiplied to x minus 2. I'm just putting the 7 first because people see the distributing much easier this way. And I'm going to go ahead and distribute that and get 7x minus 14. Because we don't have a log on both sides, I can't just say 7x minus 14 equals 2. So what we do is we convert to exponential. And when we do this, we're going to do 2 squared equals 7x minus 14. So then we're going to add 14 to both sides. And I'm running out of room here, so we get 18 equals 7x. Divide by 7, and let's see, 7 goes into 18 2 whole times with 4 7s left over. Or if you just used the calculator and did that, you would have about 2.57. All right, now before we assume that that is the correct answer, let's make sure it doesn't make any logs equal to 0. Or not equal to 0, but rather make any logs not be positive. So if I look here, I have this argument of x minus 2. If I replace x with 2.57, 2.57 take away 2, we're still positive. So this answer is okay. You could have left it in the mixed number form. All right. Here's another one. On this one, to solve this, we have to get the log part by itself first. So I'm going to add 3 to both sides, and we get 8 times log base 8 of 10m minus, or plus 2 equals 8. Divide by 8 on both sides. You get log base 8 of 10m plus 2 equals 1. So now what we do is we write this to exponential. convert to exponential. So 8 to the first equals 10m plus 2. And I know you all know how to solve this out. 6 equals 10m. Divide by 10. You get m equals 0.6. Again, make sure you check and see if plugging that number in for m is going to make that negative. Let's see, you're taking 10 times a positive number and then adding 2 to that, so that is not going to make this invalid, so that works. Okay? All right. The last thing that I want to talk about are a couple of special logarithms, and these are ones that you haven't ever seen in this unit before. E is going to be an irrational number, which is about equal to 2.57. Okay? So we use E kind of like we would use pi. It's just a number. It looks like a letter, but it's not. Okay? So when we look here, let's talk about a couple of common logarithms. In our society, we use a base 10 number system. So we don't usually write log base 10. If there is a log that has a base of 10, we just write it as log x, which is understood to mean log base 10 of x. Okay, so it's going to be really important that you know that. And likewise, the natural log of x, so this thing is called a natural log. Okay, we write ln, not sure why it's not in L, but that is an L. ln of x, so natural log of x, is the same as saying log base e of x. So just note that e and natural log cancel each other out. Okay? So we would get our calculator out, and I'm going to pull one up here just real quick. Show you a couple things here. You want the scientific version. If you tried to type in log 3, this calculator I have to hit the 3 before I hit the log button. But most calculators you'll do log and then 3. When you put that in, you get like 0.477. For the next one, natural log of 3, I hit 3, and then I hit the natural log button, which looks like ln. Now again, sometimes you have to type the natural log button first and then hit the 3. Notice I get 1.099. Also, sorry that you're hearing that scratching sound in the background. I am doing this from home, and I have a kitty that is scratching. Hey! Let me pause for a second. Okay. All right, so how do we solve equations that involve these? Well, let's take a gander. For this next one, notice here these have natural logs, but we have a plus sign between them. So we are still condensing, and I have a plus sign, so that means I'm going to use the product property. So I'm going to have natural log of 4x equals 2. To solve this, I am going to cancel out this. So remember, natural log, this is the same thing as saying log base e of 4x equals 2. So to cancel this out, or to rewrite this, I'm going to go e to the second equals 4x. I have to use a calculator to figure out e to the second. There's no way to do that just knowing it off your brain, because e is an irrational number. All right, looks like I get about 7.389. And that's just me using the calculator. So I'm going to divide by 4, and I get x is about equal to, let's see what we get, 1.85. We'll just round to 2 places here. Okay. Next problem. This time we have to get the e part by itself. So I'm going to subtract 2 from both sides first, and I get 4 times e to the 2x equals 14. Divide by 4. I get e to the 2x equals, let's see, 14 divided by 4 is 3.5. when you have an equation that has e in it, and you're trying to get that exponent out of the top there, you're going to convert this to log form. So this would be log base e of 3.5 equals 2x. But just note that log base e is the same as natural log. Okay, so now I'm going to use my calculator and figure out the natural log of 3.5. That's about 1.253. Divide by 2, and we get x is about equal to 0.63. All right, last problem here. By the way, I didn't do this, but I should have. When I was solving the previous problem, I should have made sure that this 1.85 did not impact the argument of a logarithm. It didn't, so we were fine, but I should have made that check, and I should have made that clear that I was doing that. So sorry about that. Okay, last one, we have log x plus 15 equals 2. So remember, there's no base written here, so this means that it's log base 10. So let's be careful here. I'm going to convert that to exponential form, so 10 squared equals x plus 15. 10 squared is 100. And we get 85 is x. And again, double check, make sure that when you plug that in to your log, 85 plus 15, that is most definitely a valid answer. We don't get a negative log or log that's 0, so we are good. All right, and that is the lesson. I know this was a little bit fast, so feel free to pause as needed, go back, watch the video parts again, and once you get done with that, you'll get to practice on delta.